Welcome to our discussion on using percentages. Here are the objectives, right? We want to be able to identify and calculate percent increase and decrease questions, which are a common place of error on students. And then we want to identify common mistakes with percentages. And it's usually a lot of mistakes with just understanding how increases and decreases actually work. So in most countries, tipping your server is not expected. This is actually false. The US is one of the very few countries where you're actually supposed to tip. Most other countries don't. But in any case, the US has the highest expectations for tipping of any other country at 15 to 20% being kind of standard. Suppose you want to always tip 20%. The easiest way to calculate the tip amount is to start with 10% of the bill and then double it. Now, you could also just double it and then take 10%, right? You can do it in either way. But yes, that's very easy if you want to do 20. And if you want to do 15, the same works. Take 10% of the bill and then whatever that amount is, take half of that and add it back in, right? That'd be the next 5%. So if you don't have a calculator, you can always do those things by hand by just doing 10% and then adding half of it or taking 10% and doubling it. That's the beauty of percentages. So the next time you have trouble figuring out percentages, even if you have to do 17%, which is a horrible, number, you could do 10%. You could take half of it, which would be 5%, right? And then you could take 1% of that original number, which is usually pretty easy, right? You're just basically dividing by 100, and then double it because that's that extra 2% that you need to add up to 17. You could also take 20% and subtract 3% from it, right? You can play around with these things all day long. Once you get comfortable with the idea of being able to add things back and forth, it makes it a lot easier to tackle these types of things. So how much would 15% of a tip on 984 be, and how much would 20%? Well, take 10% of 984, which is basically 98.4%, or sorry, 98.4 cents, right? You move the decimal once to the left, and then take half of that 98 cents and add it back, and there's your $1.48. 20% is move it over, get 98.4, you double it, and there's your $1.97. Very, very simple, right? Okay, sales tax ranges anywhere from, well, 3 to 7 is kind of a medium range, but there are places where sales tax can be as high as 10, 12, even 13%. When it's a decimal percentage, if you have to do 4.2% of something, that gets a little trickier to do in your head, but it's still pretty easy. And it's nice if you just realize that when you add tax on, you're just adding it to 100, right? Because you pay 100% of the original price plus the tax. So if you want to figure out how much you're paying for something when you add on 4.2%, you're just paying 104.2% of the original price. So just take the original price, multiply it by 1.042, because as a percentage, right, this is 1.042 as a decimal. And that's what you want to do when you're dealing with them with a calculator, is use the decimal equivalents. I would never do this unless you wanted to calculate just the tax, right? If you want to calculate just the tax, then you multiply it by 0.042. If you want to more kind of normally, because in real world you just care about what the total price is, you would multiply the whole thing by 1.042 and get this number straight off rather than having to do it in kind of two steps. All right, try this. Pause it, see if you can get these answers. All right, it's pretty easy, right? You're just taking 4% of it, and that's the tax, and you add it back, or you just multiply by 1.04, and similarly for 6. All right, when finding sale prices, you can either think of it in terms of the tipping method or the sales tax method, right? Since sale discounts usually occur in increments of 5%, we can think of the same number as the tipping method. If you're trying to figure out what 40% off is, you can just do 10% 4 times, and that's going to make it a lot easier when you're trying to figure out how much you're saving. But then if you want to know, like, how much does it cost after the savings, instead of figuring out what the 40% is and then subtracting it from 496, why don't you just figure out what 60% of this thing is? So multiply it by 6, right? And then lop off some decimals, because 60%, you're basically multiplying by 0.6. So that's another way to kind of save you some time, is if you're getting 40% off, remember that you're still paying 60% of the actual price. Okay, and then of course there's always shortcuts. If you're taking 40% off, you can think about taking 50% off, which is just half, and then add 10% back, to make the math easier in your head. These are all tricks to help you out in the real world if you don't have a calculator at your disposal. But we all have cell phones, which all have calculators on them, so just slap it into the calculator on your cell phone. All right, here's another one you can try. All right, absolute change is literally what it says. It's the absolute difference between two amounts. It's the new amount minus the original amount, or the original amount minus the new amount. It really doesn't matter because you're always going to take the absolute value of it. So if you start with a small number and subtract the big number from it and get a negative, you just change that into a positive. So for instance, if a shirt was originally priced at $20 and it's now on sale for $17, then the absolute change between those two is 20 minus 17 equals 3. And if you did it the other way and did 17 minus 20 and got negative 3, you just take the absolute value of it. Okay, percent change is how much is that difference in relationship to the original amount? Because if you tell me the shirt is $3 off, I might go, okay, is that good or that bad? Because I don't know how much this shirt was originally. If you tell me the shirt originally cost $6, well, I'd tell you, well, that's a cheap shirt. But I'd also say, hey, that's pretty good. It's half off. But if you tell me the shirt was originally $30 and it's $3 off, that's only 10% off. And I'm like, big deal, right? So that's where percent change means something. It gives us more information. Instead of just telling us how much something has changed, it gives us that relative amount, how much it changed in relationship to where it started. So that's why we just take the absolute difference, right? The absolute change, divide by the original amount, and then turn it into a percentage. That's what this multiplying by 100% is because that fraction will give us a decimal, of course, and then we turn that in. Let's look at an example. So an on-campus organization is trying to increase its monthly attendance. If after some big recruiting campaign, the attendance increased from 25 to 38 people, we want to figure out what was the percent change in attendance. And then during the third meeting, only 31 people attended. So what was the percent change from the second meeting down to the third? Right now it's gone down from 38 to 31. All right, and then for advertising purposes, the last question is, they decided to promote the overall increase in attendance for the 2-month span, and since it's increased and then decreased, they now want to just calculate the percent change from meeting 1 to meeting 3. So hopefully you're starting to see that all of this really just depends on what's the starting amount and what's the finishing amount, right? Because then that gives you the change, the absolute change, and then you divide that by the starting amount. So for part A, we're talking about going from 25 to 38. That's an increase of 13. We do 13 over 25 because that's where we started, and we get 52%. It's just that simple. Okay, for part B, it went from 38 down to 31, which is a difference of 7. And remember now, what's our starting point? Well, our starting point is going from meeting 2 to meeting 3. So our starting point is 38, right? So 7 over 38, it went down by 18.42%. Okay, and then part 3, the overall change question, they started at 25, went up to 38, went down to 31. So really they went from 25 to 31, which is a difference of 6, and we're back to having 25 as the starting point. So difference over original kind of thing, or difference over starting point, and there's 24%. So that's the only kind of pitfall or place where you could make mistakes with these things. It's just not kind of understanding what the starting amount is, right? Because you're always just going to have difference over original amount. You just have to figure out what that original amount is. Okay. Percentages are very useful. They tell us a lot. There are 3 common misuses with percentages. Comparing percentages of groups of very different sizes is really bad because if you're talking about 25% of a small group versus 5% of a really large group, that might actually be the same absolute amount, right? The actual amount of people in those groups. So you have to be careful when you're comparing percentages of 2 different groups. If those 2 different groups don't have roughly the same, they don't have to be identical, but on the same magnitude, then it's not a good comparison. You don't want to average percentages. That's a bad thing. Really, you don't want to average anything other than raw numbers. So you don't want to average percentages because a percentage, right, is kind of like already an average. It's a per 100 kind of thing. So you also don't want to average averages. That's another thing that people mess up all the time. And then there's the problem of shifting reference points, and we'll talk about that a little bit more in detail later. Okay, so suppose you were told that 75% of people living in Alaska favor free skis for school children while only 40% of Californians do. Now, this would make sense because in Alaska they kind of need skis more than they do in California. But the question arises that do more Alaskans favor this than Californians? Well, you have to look at the actual populations, right? Because you have to look at 75% of what and 40% of what. So if you look at the rough populations from 2010, you can see that California is substantially larger in population than Alaska, as it is even today. So when you take 40% of a much smaller number, it's probably, quite possibly, still going to be larger. And in fact, when you do the numbers, you can see that 40% of California is a far bigger number than 75% of Alaska. Now, some of you might be going, well, yeah, so what? We still want to know percentages. We still want to know, like, for instance, if we were trying to pass a law, the law would obviously pass in Alaska because you've got 75% of the voters would vote for it, whereas it would fail in California because only 40% of the voters would vote for it. And yes, that's true, and it all depends on the question you're asking and what you're trying to determine. But just realize that percentages can oftentimes water down the data. When you're looking at a percentage, it's something based out of a whole, and when those two groups have different sizes, it's really not fair to compare the percentages of those two groups unless you're only concerned about the percentages, something like voter preferences or something where, percentages is all that matters and not raw numbers. All right, here's something you can try. Even if the total populations are very different in sizes, there are times when percentages, proportions are more appropriate for comparison. Can you think of some examples? Well, we already talked about voters for one. Maybe you can come up with some other examples as well. Okay, averaging percentages, big no-no, because you're pretty much averaging almost averages, right? So if you wanted to average those two groups of the Alaskan voters and the California voters and say, hey, 57.5% favor free skis, that's horribly wrong because 75% was 75% of a very small number and 40% was 40% of a really large number. And if you took those two groups and added them together and then counted up how many from both states, you would not get 57.5 as an answer. In fact, if you did the numbers, right, here's how many in Alaska favored it, how many in California, the total populations of the two states. So you do the total favor over the total, and it comes out to be about 41%, which is a huge difference from 57.5. So do not average percentages. The only time you could average percentages is if the two groups have identical numbers, right? So if you have two groups of identical sizes and you have percentages of those two groups, then yes, you can average those two percentages because when you average the two groups, they're equally weighted. But since that rarely ever happens, it's safest to just basically say don't ever average percentages. Okay, the last one, the shifting reference points. So here's an example that'll hopefully highlight what the heck this means. Campus police report that car break-ins on campus decreased by 25% this year compared to only a 20% decline the previous year. They promoted the fact that their law enforcement efforts reduced the number of break-ins more this year than in the previous year. Is that true? Right, so they're saying it went down 25% this year. Last year it went down by 20%. So is that, have they reduced the number of break-ins? It's obvious that they have decreased the percentage, but have they decreased the number? And the answer is quite possibly no. Think about if you started with 10. If you go down to 8, that's a 20% decrease. If you now go down to 6, that's a 25% decrease, and you have the exact same break-in. Let's say you started with 100, right? You had 100 break-ins the first year. So now you're down to 80 the next year because that's a 20% decrease. And then a 25% decrease in here would be another 20 off, right? And you'd be down to 60. And you see that you get the same thing where it's still the exact same number. You've lost 20 each year, right? There are 20 fewer break-ins each year, whereas in their example, there were 2 fewer each year. So you cannot compare percentages that come from two different places, right? That's what I mean by shifting reference point, right? The 20% decrease came from the original, which was here in 2009, right? That's its reference point. But the 25% increase came from the 8 from the next year, a different reference point, right? It's being divided by a different original, right? It's always difference over original. When you put in a different original, you're no longer comparing differences because they have different originals. And that's basically what we're describing here. You don't want to do that. So don't average percentages. Be aware of shifting reference points. And don't compare percentages from two groups with two different amounts, which is really the same thing as shifting reference points, right? In both the shifting reference point and different groups problems, the problem is your original number, right? The thing that goes on the bottom of your percentage could be vastly different from one to the other. All right, that's